Welcome to AP Physics C. I'm Vincent. My teammates Jake Barton, Condi Wang, and JP Lee. We designed this lab together, so please enjoy it. In this diagram, as you can see, there are two forces are involved. First is, as you can see, it's here. F1 equals to mg sine theta. The second force is m minus kt times g. K is the amount of mass losing per second. So the unit is kg per second. And our essential question is asking for how far will the cart go before it stops. So we're basically looking for delta x. Alright, so I'm going to explain the mathematical part of this lab. First, we have these two forces, and we know F net is just the difference of the two. And F net equals to ma, and a, which is dv dt, would equals to the difference. So now we have an equation. Alright, so what I did was I divided everything by m total, and what we're going to do next is by multiplying both sides by dt, so we would have a Alright, so because m total equals to the total amount subtract by the amount of mass that is losing per second, we would have the integral of dv equals to this equation, dt. And then my partners collected the data. We have the data right here. Then we plug in all the data back into the equation. That's what we get. We used a software called Wolfram Alpha to calculate the value of c and the integral of this, the solution of this integral. So that's what we get here. C is minus 8,632 minus. Now we obtain a function of velocity in terms of t, right here. I then set the function equal to 0, because we're looking for the displacement when the cart stops. The keyword is stops. That's when the velocity is 0. And I got two x points, two zeros. And because the first one is smaller than 0, then it's reasonable to conclude that it can't be a solution. So t2 equal to 3.11899. It's about 3 seconds. That's the time when the cart stops. However, we're looking for this displacement, and we only have a function of velocity. So what we need to do is we need to take the integral of velocity function again. And as you can see, I plug into Wolfram Alpha, I find the value of c. And now we have a function xt, the displacement function. If you can still remember, this is a value of t when the car stops. We plug that back into the displacement function, and we get the displacement when the car stops. We run the lab, and you can see how we did it in another YouTube video. I will attach the video to this video, and this is the result. X initial, X final, and the delta X. And this value is really close to our predictions, and the error is actually about 2.76%, which is really small. And we thought about it, and we concluded that the error may caused by the frictions of the cart's wheel. Sorry, I reword this. So we conclude that the error probably is caused by the friction between the cart's wheel and the contact surface, and also the drag force, the imperfection of the equipments we were using. But overall, it's pretty good. Thank you for your patience, and I hope you enjoy our lab. Have a good day.